still looking at the synthetic division stuff, but we're going to also take a look at log division. So synthetic division is nice because it's fast, but it only works if we're dealing with a linear divisor. So if we're dividing by some linear term, that's where synthetic division will help us. Anytime it's nonlinear, we'll have to use this log division. So for the first couple problems tonight, they have you do log division with linear terms, and we'll just kind of work through and show how it works with both and get practice of that. Before we get into it, though, let's kind of talk about log division, because some of us probably haven't seen that since like elementary school, unless you did it on Khan Academy the other day. Okay, and so let's say we're doing something like 23 being divided into like 526 or something like that. Okay, how would I do that? Well, hopefully we remember way back when you go, okay, well, how many times does 23 fit into 52? Well, first of all, how many times does it fit into 5? It doesn't. So how many times will it fit into 52? We'd say put the 2 up there, and then we would do the 2 times our 23, and so we'd end up with 46. And then we would take this and we'd subtract it from each other. And we'd have 52 minus 46, which is 6. And then we would bring down that next term of a 6. And we'd see, well, how many times does this fit into it? Lauren, Jackie, hi. Okay, how many times does 23 fit into it? Again, it doesn't quite fit in there 3 times, so this would be twice again. So then we take that 2 multiply, which would give us 46. And then when we subtract, we'll end up with 20. And we could go into a decimal and continue if we wanted to. Otherwise, we could just say that this would go in 22 times with, whoops, too fast for it, with a remainder of 20. Okay, now, how the book is going to ask you to do it, this is where I think the confusing part comes in from tonight, is the way the book's asking you to give the answer. So it'll say, give the answer in dividend equals divisor times quotient plus remainder. Whole bunch of vocabulary. Okay, so the dividend is the top. Okay, so in this case, what we were dividing, so this is the 526, time, or equals our divisor, what we're divided by, 23, times our quotient, which was 22, plus our remainder, which is 20 in this case. Okay, so this is how it asks you to give this particular answer. Later on, it will also give it in a format where it says that our dividend over divisor equals quotient plus the remainder over the divisor. Okay, so this one actually might make a little bit more intuitive sense. Be like, oh, well, I did 526 divided by 23. That equaled 22 plus 20 over 23, because that was my remainder, the 20 divided by 23, which is some decimal, right? And so that might make a little bit more intuitive sense. But then we're going to also look at this other look. And the way we get back and forth between these two is you just multiply both sides by the divisor. So if I multiplied both sides by 23, I'd be left with 526. 22 times 23 is 22 times 23, whatever that ends up being. And then 20 over 23 times 23 is just that 20. So that's how we move back and forth. So we just multiply by that divisor. So that's how it would work if we were doing it with just numbers. So let's see how that works with polynomials. We're going to do the very similar steps. We're going to end up with this x minus 2. That's our divisor. We're going to divide that into our dividend, which is our top. And then we're going to take a look at how many times this works in, and we'll see if there's a remainder. Okay, so how many times does x go into x cubed? Or what times x gives us x cubed? X times x squared. Good. So this will be x squared is what we would multiply by, or if we factored it out, might be another way to think about it. Then we can take this, and we're going to say we're going to take that and multiply it by this, which will give us x cubed minus 2x squared. And then we'll just subtract this whole thing. So we'll end up with x cubed minus x cubed is 0. That's what we're hoping for. Negative 5 minus a negative 2 is like plus 2. So this will give us a negative 3x squared. We'll bring down that next term just like we would with long division. This would be minus 4x. And then we'll do this process again. How many times does x go into a negative 3x squared? Or what times x will give us negative 3x squared? Negative 3x. Good. And so then we just repeat this process. So we're going to say, all right, take that negative 3, multiply it by that divisor, see what we end up with. So we'll get negative 3x squared plus 6x. And then we'll subtract those from each other. So negative 3 minus a negative 3, it's like plus 3, so that's our 0. Negative 4 minus 6 more gives us negative 10x. We'll bring down that next term. So we have plus 23. And then we do that step one last time. So how many times does x go into a negative 10x? Well, what times x gives us negative 10x? Negative 10. Good. And we'll do that same process. What's negative 10 times the x minus 2? So we'll end up with negative 10x plus 20. We'll subtract those from each other. Negative 10 minus 10 is 0. 23 minus 20 is 3. So our remainder here is going to be 3. Now when we go to give it in the format they're asking for, our dividend, which is at top, you're going to have your x cubed minus the 5x squared minus 4x plus 23 equals, I'm going to probably run out of room here. Let's shift this over really quick. Equals our divisor, which was the x minus 2, what we divided it by, times the quotient, which is what we're left with, which is this x squared minus 3x minus 10 plus the remainder of 3. So this becomes the answer in the format they want given to us. So that becomes that quotient, or dividend equals divisor times quotient plus remainder. So we can bring that. Whoops. Here's where the freak out. Whoop, crashed it. Grades, yay! We get posted to the internet. Open. Awesome. Alright. Rio. Alright. That's what I get first. Okay. There we go, we're back. Let's see if we can bring that all over here now without crashing it this time. There we go. Okay. So that's where we started. That was the process, and this is how we go back to it. Okay? Alright, anything? Does that kind of make sense? Yeah. So this is the longer way around it. Let's think about how we could do the same thing if we had it with just synthetic division, because this is what we're more familiar with. What would be my number in the box? 2. Good. So 2 would be my number in the box, because that's what we're going to divide by, is that x minus 2. Okay? We're going to do the same problem, but we're going to do it with synthetic division, just to see how it works. Okay? Because you're going to see that this actually goes way faster. So then 1, negative 5, negative 4, 23. We'll bring that first term down. This is just 1. Okay, and then I don't actually have this posted online yet, so I'm going to teach through this a little bit. So synthetic division, we grab all the coefficients, and then we have that number. We'll bring the first term down, and then we'll multiply the box times that number. So we'll get the 2. We'll add the column, so -3 times 2 is -6. We'll add -10. Then we'll multiply -20. We'll add, gives us 3. And so here, you'll be able to identify the exact same thing we just had. So you've got your dividend, the top, which is the x cubed minus 5x squared minus 4x plus 23. Oops. Equals our divisor, which was this x minus 2. So this was the dividend piece. There's our divisor. So this is that x minus 2. Times our quotient. That's what's left over. There's our x squared minus 3x minus 10 plus our remainder. There's our remainder, 3. Okay, which gives us the exact same thing, but a whole lot faster.
How'd you know to put in 2?
I put in 2 because x equals 2 creates that perfect factor. So just like we done last week, I knew that 2 was what that division piece was.
Okay.
Okay. All right. So what we'll do tonight is we'll do a handful of these with just synthetic division, because you can do synthetic division with the linear format. But you need to know how to use that long division, because problem number 31 or 33, whichever one you got to do tonight, isn't linear, and so the only way to deal with it is by doing long division. So a couple more quick examples. We looked at number 13. We'll use synthetic division for a majority of tonight's problems. So let's just use synthetic division here for 13. What should I pick for my number in the box? 3. Good. So 3 will be in the box. My coefficients are 2, -5, -3. We'll bring the 2 straight down. We'll multiply. We'll add. We'll multiply. We'll add. Hey, cool. What's that mean? It's a perfect factor. Okay? So if I give this one, we're going to have our dividend, which is the 2x squared, minus 5x minus 3 is going to equal our divisor, which was that x minus 3, times our quotient, which is 2x plus 1, plus our remainder. What's my remainder? 0. So there we go. It's perfectly factored. Okay. So synthetic division, again, is going to save us a lot of time. But when does it work? What does it only work with for division? Linear factors. Has to be a linear factor. Yes, Ben.
So on that problem, there was one, you had the 2x plus 1 or whatever it was.
Mm-hmm.
Is there only an x squared? There's 3 of the
3 numbers.
Coefficients coming right down. So if it's only 2, then it's going to be just x.
Correct. So we'll good question. We'll explain it again. Whoa, why is this thing tweaking? Stop tweaking. Please don't crash. Don't crash. Okay. All right, so if we look at something like this, stay with us. Okay, so I've got my dividend on top. There's my new divisor. So what am I going to put in the box?
Minus 1.
-1. So -1 goes in the box. Our coefficients are 1, 5. How many x's do I have?
0.
I have 1x cubed, I have 5x squared, and Henry, I have 0 x's. So we got to make sure we put 0 in for the x value. Okay, so similar to what you were just asking, Ben, we got to make sure we keep that placeholder. Okay? And then 7. Then we can use our synthetic division. We'll bring that straight down. We'll multiply. We'll add. We'll multiply. We'll add. We'll multiply. we'll add. Okay? So again, these all represent, here's my remainder. There's my x to the 0 power, or the constant term, so to speak. There's x squared. If I had more, there'd be x cubed, x to the 4th, and so on. Yeah.
How'd you get that 0 again?
I got that 0 because my placeholder. So my coefficients, this is the same as x cubed plus 5x squared plus 0x plus 7. So my coefficient for my x value is 0.
Okay. So why on the last one was only 2?
Because I was taking a quadratic and dividing by linear, so it actually left us with 2 linear factors. So in this one, because I start with a cubic, since I'm going to pull out a linear, the expectation is there'd be a quadratic left over. We're just going to reduce it by 1 power. So here, our final solution then would be our dividend. So this x cubed plus 5x squared plus 7 is going to equal our divisor, which is the x plus 1, times our quotient, which is the x squared plus 4x minus 4, plus the remainder, which is 11. Okay. And then just to show you, here's the complicated one you'll see, and it didn't ask it on this question, but it did the one before. The other way it could ask for the answer is the dividend over divisor, which is basically your initial starting point. So it would be this 5x squared plus 7 over our divisor, which is the x plus 1, equals our quotient, x squared plus 4x minus 4, plus your remainder over the divisor. So that would be the other format, is if we had it divided by the divisor still. That one I think is the more confusing looking one. I would prefer you give your answers like this most of the time, and specifically on the test, that would be the easier way I think to write it. Either way is acceptable, both are correct. Just be able to understand both of them. Okay? All right, and then the very last one we're going to have today is going to be doing long division with something not linear. So let's take a look at number 32, I believe. All right, so if we do number 32, as soon as you see a divisor that's not linear, instantly we should start thinking, I can't do synthetic division anymore. We have to use long division. And there will be one on your test that will be where you have to use long division. Okay? So as soon as you see a nonlinear divisor, we have to use long division. So we'll have this x squared minus 2, and we're going to divide that into your x to the 4th plus 3x cubed plus 2x squared minus x minus 5. Okay? So same approach as what we did earlier, but now it's a nonlinear term. So x squared, how many times does that go into an x to the 4th? Or what times x squared gives me x to the 4th? X squared. Okay, and then we're going to take that x squared value, okay, that term, we'll multiply it by the divisor. So we'll end up with x to the 4th minus 2x squared. Do I have any x cubes? No, because it's missing that x term in the divisor. We're not going to have an x cubed term. So same approach though. We're going to subtract everything. So x to the 4th minus x to the 4th is 0. 3 minus 0 still gives us 3x cubed. 2 minus negative 2 is like plus 2, so this would be plus 4x squared. And then we'll bring down that next term, which is this negative x. We'll repeat this step. So x squared times what gives me 3x cubed? 3x. So a positive 3x. We're going to take that 3x and multiply it by that divisor. And so we'll see we end up with 3x squared, or 3x cubed minus 6x. We'll subtract these two from each other. We'll end up with 3 minus 3 is 0. 4 minus 0 is 4. So we have 4x squared. Negative 1 minus negative 6 will give us plus 6. So that's a 5x. And then we'll bring down that very last term. X squared times what gives us 4x squared? 4. And then we'll take that last one. We'll multiply it by the divisor one last time. We'll see that we end up with 4x squared minus 8. And when we subtract this out, 4 minus 4 is 0. 5 minus 0 is 5. And negative 5 plus 8 is 3. So we'll end up with this as our remainder. So when we go to give that final answer, we'll see that this will equal our dividend. So x to the 4th plus 3x cubed plus 2x squared minus x minus 5 equals our divisor, which was x squared minus 2 times our quotient, which is that thing remaining, x squared plus 3x plus 4 plus our remainder, which is 5x plus 3. Okay, so when it's nonlinear, it kind of turns into an ugly train wreck of a whole bunch of stuff. But it's that same process to just work through them piece by piece, and you'll eventually see that we end up with our dividend, divisor, quotient, and our remainder. All right.
Did you put the x squared or the 2x squared on, because if you multiply if you multiply x squared minus 2, it won't go into x to the 4th or 3x cubed. Like, you started
For you.
Yeah, the first step.
So the first step, how many times does x squared go into x to the 4th? Goes in x squared times. So that's where I get my x squared. X squared times x squared minus 2 gives me x to the 4th minus 2x squared.
Oh, so that's why you put it.
That's why I don't have, because I want to collect my like terms, so I stacked them over each other. Then I subtracted it through. Bailey?
Can you please show 31